Alright, let's take our examples on electrolysis. The first question. Calculate the mass of copper deposited in the electrolysis of copper 2 tetraozosulfate 4 solution by a current of 0.2 ampere flowing for 1 hour 20 minutes. Flowing for 1 hour 20 minutes. We're given copper as 64, our Faraday's constant as 96500 coulomb per mole. Alright, based on the formula given, we have our time in the question is 1 hour 20 minutes. At this junction, we have to convert our time to seconds. So our 1 hour, we have 3,600 seconds in an hour, and we have 20 minutes, we have 60 seconds in a minute. So 20 times 60. So here we have 3,600 plus 20 times 60, we have 1,200. Here we add them together. When we are adding plus 3,600, we have 4,800 seconds. Be careful at this point not to be in a hurry. So we have in an hour we have 3,600 seconds, and for 20 minutes we have 60 seconds, make 1 minute, so we are multiplying our 20 by the 60. Okay, we put down our formula. Don't forget we are looking for mass, so we'll use the formula that connects mass. Mass over molar mass equals Q our Q at this point will now be what? IT, because we have been given our I as 0.2. Then we have VF. Now don't forget that for copper, the valency of copper is +2. So the mass is what we are looking for, over molar mass we are given 64, equals the current in the question is 0.2 ampere times our time. The time now is no longer 1 hour 20 minutes, but what? 4,800 seconds. We're dividing it by 2, which is our valency, times 96500 times 96500. So now you make your M the subject of the formula by cross multiplying. Make M the subject of the formula by cross multiplying. Come here. We cross multiply from this particular place. We have M equals 64 times 0.2 times 4800 to be divided by 2 times 96500. Our M equals, we have 64 times 0.2 times 4800, we have 61440. All over, we have 2 times 96500. We have 193000. Be careful at this point. So our M equals 61440 divided by 19300. Our mass that we are looking for have 64 All right, 61440 divided by the final answer to that to our question, 61440 divided by 19300, we have 0.318, approximately 0.32 grams. Now we take the explanation again. From the question, we're told that the current of 0.2 ampere flows through the salt for 1 hour 20 minutes. In 1 hour 20 minutes, we have 4,800 seconds. So we now have, from the formula, we have the mass versus the molar mass equals our current times time, all over the valency and the Faraday constant. Do not forget that our Faraday constant is 96500 coulomb per mole. So when we substitute our variables given, we have mass. The molar mass of copper given in the question is 64. The current is 0.2. Our time, which is 1 hour 20 minutes, have been converted to 4,800 seconds. Then the valency, which is the charge on the copper, is 2, divided by times the Faraday's constant. So when we cross multiply, we multiply the upper one, we have 61,440. When we multiply the denominator, we have 193,000. So when we did the math, we have 0.318, approximately a 0.32 grams of mass of copper will be deposited. Still on electrolysis, let's take the second example. Calculate the mass of silver deposited by electrolysis from a solution of silver trioxynitrate 5 placed in series with a copper tetraoxosulfate 6 solution when 0.08 gram of copper are deposited on the copper plate. We are giving Cu to represent copper as 64, our Ag to represent silver as 108, and our Faraday constant still remains 96500 coulomb per mole. Now, how do we solve this question? This is a typical second law of electrolysis question. At this point, I want you to pay attention to those things given. You have been given the mass of copper. You have also been given the molecular mass of copper. If you know the mass, you know the molecular mass, and we also know the valency, because it is not all questions that will be given the valency. In most electrolysis questions, the valencies are not given. So we know that the valency of copper is 2. We'll now look or use the formula that connects these variables given. So we'll make use of mass over molar mass equals Q over Vf. Why are we using this formula? We are using this formula because we have the mass, we have the molar mass, but we don't know the quantity of electricity passing through it. So we can get our Q since we now know the value of the V as well as F. So the mass of which compound we are looking at first is the mass of copper. So we now say mass of copper given is what? 0.08 over molar mass of copper is 64 equals quantity that we don't know, and we know the valency of copper is 2 times the Faraday constant, which is 96500. We can make Q our subject of the formula. We have 0.08 multiplied by 2 times 96500 all over 64. Our Q becomes 0.08 times 2 times 96500. We have 15440 divided by 64. Our Q equals, we have 241.25 coulomb of electricity. So this is the amount of electricity that is passing through the cells of silver as well as copper. Now, since we have gotten the quantity, we can now substitute the quantity to get our mass of silver. All right. We know the quantity now, so we now use the same formula: mass of silver over molar mass of silver equals our quantity Vf. Don't forget that our V now is the valency of silver, and you know that silver is always Ag plus. So the valency of silver at this junction is +1. So you come here, say mass of silver we don't know. Molar mass of silver in the question is 108. We already know what our Q is. Our Q is 241.25. So 241.25 all over our valency is 2 Valency here is 1 for silver times 96500. When we make our mass of silver subject of formula, we have 108 times 241.25. 1 times 96500. All right. All right. So we must take the upper value we have. This will give us 108 times 241.25 will give us 26055 multiplied by 9 divided by 96500. Our final answer is 0.27 grams. Now, from the question given, we must first of all calculate the quantity of electricity. Because if we don't know the quantity, we will not be able to solve for the mass of silver in the question. So, we know the mass of copper as 0.08. And we know the molar mass of copper as 64. Be very careful. Be very, very careful when multiplying because of these 0 digits. And your places of decimal is of paramount importance. Now, 0.08 all over 64 equals your Q all over 2 times 96500. When you multiply the numerator, you have 15440 all over 64. Our final quantity was 241.25 coulomb of electricity. Now, we are looking for the mass of silver. The mass of silver over molar mass of silver will give us the quantity. This Q is not a new Q you are looking for. We have calculated the Q as 241.25 coulomb all over V times Faraday. Now our Faraday is a constant which is 96500 and our valency of silver is 1. When you cross multiply, making the mass of silver subject of the formula, you now have 108. The 108 is the molar mass of silver. The 108 is the molar mass of silver times 241.25 all over 1 times 96500. This is what we obtained, 26,055 divided by 96500. We have 0.27 gram as the mass of silver obtained from the electrolysis involving the 2 salt solution. Still on electrolysis, let's take the third example. Calculate the current that must be passed into a solution of aluminium salt for 1 hour 30 minutes in order to deposit 1.5 gram of aluminium. We're given the molecular mass of aluminium as 27 and our Faraday constant as 96500 coulomb per mole. Now, coulomb per mole. In solving this question, you don't need to rush, because we are not given the quantity of electricity. And if we do not know the quantity, we are not going to be able to solve for the current, because our Q is always IT. So we are being asked to find the I. So what we do is to first of all calculate our quantity of electricity. What are those things we are given? We are given the mass of aluminium as 1.5, and we know the molar mass as 27. So we're going to use a formula that connects the mass and molar mass and the quantity of electricity. So we use mass over molar mass equals Q over VF. The mass in the question is 1.5. The molar mass is 27. Our Q is unknown. The valency of aluminium. Aluminium is always Al3+. Don't forget, you are supposed to know some valencies. One of them is aluminium. So the V becomes 3 times our Faraday constant 96500. We make Q the subject of formula. We have Q equals 1.5 times 3 times 96500. We also have, we divide it by 27. So we have 1.5 times 3 times 96500. We have our Q 434250 divided by 27. Our Q is 6. So this is 16083.33 column of electricity is actually being generated when a current is actually being generated. So but now, since we have gotten our Q, we can now substitute the value to get our I. Alright, don't forget, we are looking for current, and we were told that we should calculate the current that must be passed into a solution of aluminium salt for 1 hour 30 minutes in order to deposit 1.5 gram of aluminium. So this is the quantity of electricity entering the cell containing this particular salt. So now let's get the quantity, the current. Now we can calculate the current. So we say Q equals IT. We know the Q. We can make I the subject of formula, I Q over T. So our T, the Q becomes, now our I is, the I in the question given, we have to calculate the I in the question given. And the I in the question given is, the time passing is 1 hour 30 minutes. So 1 hour 30 minutes. So we break down the 1 hour 30 minutes. That's 3,600 for 1 hour seconds plus 30 times 90 30 times 60. So we have 30 times 60. That will give us 1,800. We multiply it by the seconds. So we have 5,400 seconds. So we have 5,400 seconds in 1 hour 30 minutes. So we now come here. The Q here is 16,083.33 divided by this particular value of seconds. We now have So we have 2.98 grams. So we have 2.98 grams of aluminium being deposited or liberated. We'll take it again. First of all, we need to know the quantity of electricity. How do you calculate the quantity? You need to substitute the values you are given. We are given the mass. We know the molar mass, we know the valency, and as well we know the Faraday's constant. So when we put them in the right proportion, we get our Q as 16083.33 coulomb of electricity. Don't forget that the time in the question is 1 hour 30 minutes. You have to convert 1 hour 30 minutes to seconds. So in 1 hour we have 3,600 seconds. So the 30 minutes is 30 times 60, which is 1,800 seconds. So 30 minutes contain 1,800 seconds. We add them together, we have total seconds as 5,400 seconds. We make Q here the subject of the formula. When we make Q the subject of the formula, we obtain this value as 2.98 grams being produced. Once again, you don't need to be in a hurry when you are multiplying the variables given. You need to pay close attention when multiplying those variables, because at times a single dot can alter, a dot being placed in the right position can alter the result, and there the equation you are solving becomes wrong. Example number 4. If a current of 3 ampere is passed for 60 minutes, calculate the mass of copper deposited. This is a typical examination question. How do we go about this question? First and foremost, what are those things we are given? We are given our I as 3 ampere. Our T is given as 60 minutes. Meaning that we have to break down the minutes to seconds. So this will give us 60 times 60. And that will give us 3,600 seconds. That will give us 60 times 60, 3,600. All right. We are looking for the mass. So we have to use a formula that connects the mass. We have mass of copper, molar mass of copper will now give us IT over VF. Our mass of copper is what we are looking for. We now have IT over mass of copper will now give us molar mass of copper multiplying by the mass times IT over VF. The mass of copper in the question is 64 and our I in the question is 3. Our T in the question is 3,600 seconds. Our valency is 2. Our Faraday constant is 96500. I believe we are all familiar with the valency now. The valency of copper is 2. So we multiply so we have 691.200.200. Then we have here 193. Our mass of copper will now be 691.2. We divide it by 19300. We have 35.81 grams of copper being deposited. So, if a current of 3 amperes is passed for 60 minutes, calculate the mass of copper deposited. We're only given the molecular mass of copper as 64. Since the molecular mass is 64, we know the current as 3. We break down the 60 minutes to seconds, so that's why you multiply by 60, you have 3,600 seconds. So we have mass, we are using the formula that connects both the mass and the molar mass, as well as the time, the current, the Faraday constant, and valency. So the molar mass of copper is 64 at this point. The current in the question is 3, and the time is 3,600 seconds. So the valency of copper here is 2, and the Faraday constant is 96500 constant 96500 coulomb of electricity. When you multiply the numerator, you obtain this value 691,200. Now the denominator value, when you multiply the denominator value, you have 193,000. Now when you divide, you obtain 35.81 grams as the mass of copper deposited during the electrolysis involving 3 amperes of current flowing for 60 minutes. Still on electrolysis, let's look at the uses of electrolysis. One, we have extraction of metals and non-metals. Metals like sodium, magnesium, calcium, aluminium, zinc are being extracted through electrolysis. Also, non-metals like chlorine and fluorine are also being extracted through electrolysis. We also have purification of metals. Copper, silver, mercury, and gold are being purified through electrolytic processes. Now we have electroplating of one metal by another. That's the third uses of electrolysis. Why do we electroplate a metal? We want to increase the longevity of the metal in question. We want to make sure that the metal can withstand hard usage of time. So we do that by applying the concept of electrolysis. We also have, one of the uses of electrolysis is industrial preparation of certain chemicals. Chemicals like sodium hydroxide, chlorine, hydrogen can also be produced from electrolysis of concentrated brine solution. All these chemicals are obtained as products either from the cathode or from the anode during the electrolysis of aqueous solution of brine. And you know that brine is concentrated sodium chloride solution.